The research vessel Eternal Curiosity drifted through the debris field of what had once been a small mining outpost in the Centaurus Arm. Chief xenobiologist Zilax adjusted her atmospheric tentacles, her crystalline eyes reflecting the scattered wreckage outside the observation dome. The destruction was total. Twisted metal and frozen gases painted a tragic portrait of what stellar radiation could do to an unprotected station. "Life sign confirmed," announced the ship's AI, its tone carrying the particular harmonic of uncertainty that made Zilax's species uncomfortable. "Single biological signature, impossible to classify." Captain Nenthor, his carapace glowing with the deep blue of skepticism, moved closer to the display. "Impossible. Nothing survives direct exposure to a Class 7 solar flare, especially not in this sector's radiation belt." But there it was, a steady biological ping among the wreckage. The Eternal Curiosity approached cautiously, its sensors probing the debris field. Through the quantum glass viewport, Zilax spotted movement. A figure in what appeared to be a badly damaged environmental suit was using pieces of debris to slowly propel itself toward their ship. "By the first stars," whispered Medical Officer Kriva, her bioluminescent patterns flashing in distress. "That's a human." The declaration sent a ripple of unease through the bridge crew. Humans were still relatively new to the galactic community, and their reputation was complicated. They lacked the natural defenses that most spacefaring species evolved with. No radiation-resistant scales, no backup organs, no protective exoskeletons. Yet somehow, they'd survived on their death world and reached the stars. "Impossible," Captain Nenthor repeated, but with less certainty. The radiation levels here would have liquefied their internal organs. Their cellular structure should have collapsed hours ago. The human continued its approach, using precise movements to navigate the debris field. Their environmental suit was clearly compromised. Entire sections were missing or damaged beyond function. The readings couldn't be denied. Somehow, this human was not only alive but conscious and coordinated. Bringing them aboard would be a violation of safety protocols, the security chief noted, his armored plates clicking nervously. "We don't know how they survived or what damage they've sustained." "They'll die if we don't," Zilax countered, her tentacles rippling with determination. "This is exactly why we're out here, to study and understand." The rescue operation was precisely executed. As soon as the human was aboard, Kriva's medical team rushed them to decontamination. The crew gathered anxiously outside the medical bay, waiting for answers that defied their understanding of biology. Hours later, Kriva emerged, her pattern showing the peculiar combination of professional fascination and existential dread that Zilax had come to recognize when dealing with human-related phenomena. "The human will survive," she announced, bringing up a holographic display of their patient's biological readings. "Their name is Dr. Sarah Chen, xenogeologist. She was studying mineral formations in the asteroid belt when the solar flare hit." "How?" The captain's question encompassed volumes of scientific impossibility. "Their damage control mechanisms are remarkable," Kriva explained, highlighting various biological processes in the display. "While their cells were indeed damaged by the radiation, their body immediately began implementing repairs. They have these things called stem cells that can become whatever type of cell is needed. Their immune system adapted to the radiation exposure in real time." Zilax moved closer to the display, her scientific curiosity overwhelming her natural caution. "But the suit breach, the vacuum exposure." "Humans can survive in vacuum for short periods," Kriva said, her pattern showing disbelief at her own words. "Their tissues can handle decompression far better than any species we've encountered. They don't explode or freeze instantly like our physics model suggests they should. They just endure." The medical bay door cycled open, and Dr. Chen sat up on the examination table, offering a weak smile to the assembled aliens. Her skin showed radiation burns, and medical scanners indicated multiple microfractures in her bones, yet she was conscious and alert. "Thank you for the rescue," she said, her voice hoarse but steady. "I apologize for any inconvenience. I was trying to reach the emergency beacon in Section 7 when the second flare hit." "You were exposed to 2 flares." Captain Nenthor's carapace shifted to the white of shock. "Had to keep moving." Dr. Chen shrugged, then winced at the motion. The backup generators in the mineral analysis lab were still running. "Figured if I could reach them, I could boost the emergency signal strength." The aliens exchanged glances, their various biological displays showing a mix of horror and fascination. Here was a being who, by all their understanding of physics and biology, should be dead several times over. Instead, she was apologizing for the inconvenience of saving her life. "We found no functioning generators in the debris field," the security chief noted. "Oh, I got it working," Dr. Chen said, attempting to stand before Kriva's medical field gently pushed her back down. "Had to manually reconnect the power couplings. Bit tricky in vacuum with broken fingers, but you find ways to manage." Zilax's tentacles curled in disbelief. "You performed technical repairs in lethal radiation, with vacuum exposure and broken bones." "Well, yeah," Dr. Chen replied, as if it were the most natural thing in the world. "What else was I supposed to do? Die?" And there it was, the fundamental difference that made humans unique in the galaxy, where other species accepted their physical limitations as absolute boundaries. Humans saw them as inconvenient obstacles to be overcome through sheer stubborn determination. The Eternal Curiosity would later submit a detailed report to the Galactic Scientific Council about the incident. It would become required reading at every Xenobiology Institute in known space, titled simply, "Why Humans Don't Need Armor. They Are the Armor." The Galactic Council's emergency response team arrived at New Eden Colony expecting to find ruins. Instead, they found humans thriving. Ambassador Klixta of the Vrax Imperium stood at the command center's viewport, his crystalline form refracting the light of the binary stars overhead. The scene before him defied explanation. 3 months ago, New Eden's atmospheric processors had catastrophically failed during a massive solar storm, leaving the fledgling colony exposed to toxic gases and extreme temperature fluctuations. The Council had written off the settlement as lost. No species could survive such conditions without proper environmental protection. Remarkable, isn't it? Dr. Marcus Rodriguez appeared beside him, his dark skin covered in a thin sheen of sweat. The human colony director wore only light protective gear, a fact that made Klixta's crystalline structure vibrate with unease. "We lost 90% of our environmental systems, but we adapted." Adapted? Klixta's translator struggled with the concept. "Your atmosphere is 30% methane. The temperature swings between 40 degrees above and 20 below your species' survival range. By all known biological standards, you should be dead." Rodriguez smiled, leading the ambassador through the colony's main corridor. Unlike the pristine, sterile environments of most space settlements, New Eden had been transformed. Makeshift hydroponic gardens filled every available space, their plants engineered to process the toxic atmosphere. Colonists moved purposefully through the halls, their faces marked with determination rather than despair. "When the processors failed, we had a choice," Rodriguez explained, pausing to help a group of children adjust a new filtering system they'd constructed from salvaged parts. "We could wait for rescue, or we could evolve." Evolve? In 3 months. The concept made Klixta's crystalline matrix pulse with disbelief. "Not biologically, though our bodies have started adapting to the new atmospheric composition faster than our doctors expected. We evolved our approach. See those plants?" He pointed to the surrounding gardens. "We modified them to process methane more efficiently. The children call them lung trees now." They passed through a section where the wall panels had been removed, exposing the colony's infrastructure. Humans worked in teams, constantly adjusting and modifying systems that were never designed to function under these conditions. The temperature swings should have structural integrity impossible, Klixta observed, his scientific training warring with the evidence before his sensory inputs. Oh, they were at first, Rodriguez agreed cheerfully. Lost 3 outer sections before we figured out how to use the thermal stress to our advantage. Now we harvest the energy from the temperature differentials. Turns out extreme temperature gradients make excellent power sources if you're creative enough. A young engineer approached them, her face smudged with mechanical grease. Director, we've got the new thermal exchangers online in Section 7. Efficiency's up 12%. Excellent work, Sarah. How's your father doing? Better. The new bacterial treatment is helping his lungs adjust to the methane exposure. Medical thinks he'll be back on full shifts by next week. Clixta's structure nearly destabilized at this casual discussion of surviving what should have been fatal exposure. You're allowing damaged individuals to continue working. Rodriguez's expression grew serious. Ambassador, every person here has been damaged by your standards. We've all experienced toxic exposure, temperature stress, radiation, but humans don't break easily. We heal, we adapt, we overcome. More importantly, we help each other overcome. They reached the colony's medical center, where Clixta expected to find scenes of suffering. Instead, he found an organized operation where patients simultaneously received treatment and contributed to the colony's survival. One man was teaching children while receiving respiratory therapy. A woman with bandaged hands was dictating technical specifications to a team of engineers. When the processors failed, Rodriguez continued. Standard protocol said we should evacuate to the emergency bunkers and wait for rescue. But the bunkers would have only sustained us for a month, and we knew help was at least 3 months away. So we did what humans always do. We got creative. He led Clixta to a laboratory where colonists were cultivating what appeared to be modified bacterial colonies. We found bacteria in the deeper rock strata that naturally process methane. Our geneticists modified them to work with human biology. We're literally changing ourselves to survive here. This violates dozens of Galactic Council safety protocols, Clixta noted, though his tone carried more awe than censure. Survival often does, Rodriguez replied simply. The Council builds protocols around the assumption that life is fragile, that beings must be protected from their environment at all costs. Humans, we have a different perspective. We don't see ourselves as separate from our environment. We see ourselves as part of it, capable of changing it, and being changed by it. A warning klaxon sounded, and colonists moved with practiced efficiency as another temperature swing approached. Clixta watched in fascination as humans switched systems, rerouted power, and adjusted their activities with seamless coordination. You've turned catastrophic system failure into a sustainable way of life, he observed. Rodriguez nodded. That's what we do. Humans don't just survive. We adapt, we improve, we thrive. Every crisis is an opportunity to become stronger, more resilient. As they returned to the command center, Clixta composed his report to the Galactic Council in his mind. How could he explain that this colony hadn't just survived? It had discovered entirely new ways of existing. That these humans, through what other species would consider a disaster, had pioneered environmental adaptation techniques that could revolutionize colonization throughout the galaxy. I must ask, he said finally, weren't you afraid? When everything failed, when death seemed certain. Rodriguez looked out at his thriving colony, at the humans who had refused to accept impossibility as a limitation. Of course we were afraid. But humans learned long ago that fear is just another form of energy. You can let it paralyze you, or you can use it to fuel something amazing. Outside, the toxic atmosphere swirled with new colors, the result of the colonists' biological engineering efforts. What had been a death sentence had become a canvas for human ingenuity. New Eden hadn't just survived. It had become something entirely new, a testament to humanity's greatest strength, the ability to transform their greatest challenges into their greatest achievements. The Galactic Endurance Championship was meant to showcase the peak physical capabilities of every spacefaring species. Instead, it became a lesson in human persistence that would reshape the galaxy's understanding of endurance itself. High Commissioner Zextal watched from the observation deck as competitors from 37 species prepared for the race across Kepler 186's harsh terrain. His crystalline eyes focused on the sole human participant, Catherine Wu, as she performed simple stretching exercises among her far more imposing competitors. "She cannot seriously intend to compete," remarked Grand Marshal Vexnor, his armored exoskeleton gleaming in the red dwarf's light. "The Thraxian contestants have redundant cardiopulmonary systems. The Meridian racers can photosynthesize energy directly. What does she have?" "Sweat," replied Dr. Aidan O'Connor, the human medical observer, without looking up from his datapad. "And a really interesting evolutionary history." The race began at local dawn. The course was deliberately brutal. 500 kilometers across terrain ranging from frozen tundra to active volcanic fields. Most species had evolved or engineered specific advantages for such challenges. The Thraxians' multiple hearts pumped oxygen-rich blood through their massive frames. Meridian athletes could absorb solar radiation for energy. The serpentine Nagai could enter low-energy states between bursts of activity. Catherine Wu just ran. Hour after hour, she maintained a steady pace while other competitors surged ahead. When the first rest station appeared at the 100-kilometer mark, several racers had already dropped out, their specialized biology overwhelmed by the sustained exertion. Wu paused only long enough to drink water and pour some over her head before continuing. "Fascinating," muttered Dr. O'Connor, monitoring the biometric feeds. "Her core temperature should be dangerously high, but the evaporative cooling is working perfectly. 4 million years of evolution refined into a single droplet of sweat." By the second checkpoint, the race's character had changed. The early leaders were struggling, their biological advantages becoming limitations. The Thraxians' powerful bodies demanded enormous energy inputs. The Meridians faltered as cloud cover reduced their solar efficiency. But Wu kept running. "She's actually getting stronger," observed one of the medical monitors in disbelief. The human's pace had increased slightly, her movement becoming more efficient as her body adapted to the effort. "Persistence hunting," O'Connor explained to the bewildered alien observers. "Before we had tools, before we had weapons, humans hunted by simply following prey until it collapsed from exhaustion. We evolved to just keep going." The third checkpoint brought more withdrawals. Even the mighty Thraxians, with their multiple hearts and enhanced lungs, couldn't maintain the pace. The remaining competitors watched in growing unease as Wu ran past the rest station, with nothing more than a water refill and a protein concentrate. "Her muscles should be failing," Zextal noted, reviewing the medical data. "The micro-tears, the metabolic stress." "Oh, they are," O'Connor confirmed cheerfully. "But human muscles don't just break down. They rebuild stronger. Every step is literally making her more capable of taking the next one." As the race entered its final phase, only 5 competitors remained. The volcanic fields posed a new challenge. Highly toxic gases vented from fissures in the ground, and the temperature soared well beyond what most species considered survivable. Wu's pace never faltered. Her body was now functioning in what other species would consider a critical state. Heart rate elevated, muscles flooding with lactic acid, core temperature pushing safety limits. But millions of years of evolution had prepared humans for exactly this scenario. "You see," O'Connor explained to the increasingly fascinated officials, "humans don't have the best cooling system, or the most efficient muscles, or the largest energy reserves. What we have is the ability to push past what other species consider absolute limits. We can run while overheated because our sweating system is remarkably efficient. We can keep moving with depleted muscles because our bodies are adapted to rebuild during motion. We can function while partially oxygen deprived because our brains evolved to maintain critical functions even in extreme conditions." Catherine Wu crossed the finish line alone. The nearest competitor was 2 hours behind. She showed signs of extreme exertion, dehydration, muscle stress, metabolic strain, but remained standing, conscious, and remarkably coherent. "How demanded Vexnor, his exoskeleton plates clicking in agitation. How can she still be functioning? Wu took a long drink of water before answering. Because stopping wasn't an option. The human body is an incredible machine, but our greatest strength isn't in our muscles or our cooling system or our efficient vital movement. It's in here, she tapped her temple. We decided, long ago on the savannas of Earth, that we would not be limited by our body's complaints. We learned to push beyond pain, beyond exhaustion, beyond what seems possible. The medical data from the race would be studied for decades. It demonstrated something that many species found difficult to comprehend. Humans weren't extraordinary because they could avoid the physical stresses of extreme endurance. They were extraordinary because they had evolved to endure them, to push through them, and ultimately, to grow stronger because of them. As Catherine Wu received her medal, Dr. O'Connor shared one final observation with the astounded officials. You know what's really remarkable? She's not even close to the human record for endurance events. Wait until you see what we can do when we're really pushing our limits. The Galactic Endurance Championship would never be the same. More importantly, it had provided yet another piece of evidence that humanity's greatest strength wasn't in what their bodies could resist, but in what they could endure and overcome. The distress call reached the Galactic Emergency Response Station during the third shift. Deep in the Carina Nebula, a mining operation had collapsed, trapping workers from 6 different species beneath kilometers of radioactive rock. The situation was classified as unsurvivable by standard protocols. Commander Raxtel of the Hexapod Collective reviewed the data with growing despair, his sensory appendages drooping. The trapped miners had perhaps hours before the radiation and toxic gas would overcome even the most resistant species' natural defenses. The rescue shaft would take days to dig. Send the standard regrets to their families, he began, but was interrupted by the arrival of the Human Emergency Response Team. Captain Maya Patel strode into the command center, already suited up in what looked to the aliens like remarkably inadequate protective gear. Behind her, her team was prepping equipment that seemed absurdly simple compared to the advanced rescue machinery that surrounded them. We're going in through the thermal vents, she announced, studying the holographic display of the mine complex. The radiation will have weakened the structural supports, but that works in our favor. We can move faster through partially collapsed sections. Impossible, Raxtel's translator chittered. The thermal vents are reading at 180 degrees Celsius. The radiation levels are beyond survivable limits. The toxicity. With respect, Commander, Patel interrupted. Impossible is what humans do best. We've got 6 hours before those miners run out of air. We're going in. Before Raxtel could cite another regulation, the human team was moving. They carried lightweight gear, medical supplies, and what looked like primitive rope systems. The commander watched in horrified fascination as they prepared to enter an environment that his species classified as an immediate death zone. You should know, Dr. James Chen, the team's medical officer, explained while checking his equipment. Humans have a long history of going into places we absolutely shouldn't survive. Mining disasters on Earth taught us that sometimes the only way out is through. The rescue operation that followed would be studied in emergency response academies across the galaxy. The human team moved through the superheated vents with a speed that defied biological logic. Their cooling systems were overwhelmed within minutes, but they continued. Their radiation monitors screamed warnings, but they pressed on. In the command center, alien medical officers watched in disbelief as the humans' biological readings reached levels that should have indicated system failure. Heart rates soared, core temperatures rose dangerously, radiation exposure mounted, but they kept moving. Their tissues are literally cooking, one medical officer observed, his tentacles writhing in distress. The radiation is causing cellular breakdown. They should be incapacitated. That's the thing about humans. Dr. Chen's voice crackled over the comm, strained but steady. We don't stop when our bodies tell us to. We stop when the job is done. 4 hours into what should have been a fatal mission, Captain Patel's voice broke through the static. "We've reached them. 6 survivors. Beginning extraction." The rescue itself bordered on miraculous. The human team had to make multiple trips through the death zone, each time carrying or guiding survivors who would have died without the protective gear the humans sacrificed for them. They rigged impromptu pulley systems, transformed toxic waste containers into emergency shelters, and performed emergency medical procedures in conditions that should have made fine motor control impossible. When the last survivor was pulled to safety, the human team emerged. Their skin was burned, their bodies showed signs of severe radiation exposure, and their medical readings were off any conventional scale. Yet they remained not only conscious but functional, immediately helping to treat the miners they'd rescued. "I don't understand," Raxtal admitted, watching as the humans received emergency treatment themselves. "Your bodies were failing. Every diagnostic showed critical system collapse. How did you keep going?" Captain Patel, her skin blistered from heat and radiation, managed a tired smile. "Because they needed us too. Human bodies are remarkably sturdy, but our real strength isn't in our flesh and bone. It's in our absolute refusal to accept failure when lives are on the line." Dr. Chen, monitoring his team's recovery, added, "Humans evolved in an environment that was constantly trying to kill us. We learned early that physical limits are often more negotiable than they seem. When we absolutely have to, we can push ourselves far beyond what should be possible." The medical data from their suits told an extraordinary story. The human rescuers had endured conditions that would have killed most species instantly. Their bodies had been literally breaking down, proteins denaturating, cells dying, but they had somehow kept functioning through sheer determination. "It's not that we're invincible," Patel explained later during the official debrief. "We feel every bit of damage we take. The heat burns us. The radiation sickens us. The toxins poison us just like they would anyone else. The difference is, humans evolved to keep going anyway. We can function at surprisingly high levels even with severe system damage." The incident revolutionized galactic emergency response protocols. Human teams became essential components of rescue operations throughout known space, not because they were immune to damage, but because they could continue to function effectively even while being damaged. As Commander Raxtal noted in his final report, the true advantage of human emergency responders lies not in their ability to avoid injury, but in their capacity to continue performing complex tasks even while injured. They do not simply endure. They remain operational under conditions that would incapacitate most species. This is not due to superior physical resistance, but rather to an apparently unlimited ability to prioritize mission completion over physical well-being. The report concluded with a note that would become famous in rescue operations across the galaxy. Humans do not survive because they are stronger. They survive because they simply refuse to stop, even when survival seems impossible. In doing so, they often redefine what is possible for everyone else. The Galactic Academy of Advanced Survival Studies opened its doors on a planetoid that most species considered uninhabitable. This, Professor Elena Santos would explain to each new class, was precisely the point. "Welcome to what many call the human school of impossible survival," she addressed the assembled students from 30 different species. The lecture hall itself was a testament to adaptation. Built into a natural cave system, powered by geothermal energy from the planet's unstable core, and designed to accommodate beings from every known environmental requirement. "You're here," she continued, "because your species has recognized something crucial. Survival isn't about being the strongest or having the best natural defenses. It's about adaptation, innovation, and most importantly, the will to continue." A Meridian student raised their photosensitive appendage. "But Professor, humans lack basic survival adaptations. No natural armor, no radiation resistance, no backup organs. How can you teach survival?" Elena smiled, activating the holographic display. It showed scenes familiar to many. The New Eden colonists thriving in toxic atmosphere, Catherine Wu's legendary endurance race, the mining rescue that defied death itself. Because humans don't survive through natural advantages, we survive by turning disadvantages into strengths. Every student here has impressive natural defenses, armor plating, regenerative abilities, multiple organ systems. But what happens when those defenses fail? The room grew quiet. It was a question many species preferred not to consider. Humans, Alina explained, never had the luxury of perfect natural defenses. Every step of our evolution was a lesson in overcoming limitations. Now we're here to teach you what we learned. The Academy's curriculum was unlike anything in galactic education. Students weren't just taught survival techniques. They were taught how to think like humans. The first lesson always shocked them: intentionally experiencing failure. Your environmental suits are designed to fail in 15 minutes, Alina announced during a practical exercise on a volcanic plain. Your task isn't to prevent the failure. It's to continue functioning after it happens. The alien students were horrified, but they learned. They learned that their bodies could endure more than their instincts suggested. They learned that improvisation wasn't just a skill. It was a way of thinking that could mean the difference between life and death. One day, a Thraxian student with 3 backup hearts asked the question that many had wondered: why do humans teach us? Why share these survival techniques that give you an advantage? Alina's response became one of the Academy's most quoted teachings. Because the greatest survival skill humans ever developed was cooperation. We survived on Earth, not because we were the strongest, but because we learned to work together, to share knowledge, to help others survive. The Academy's influence spread throughout the galaxy. Its graduates didn't just survive crisis situations, they revolutionized how their species approached survival itself. Thraxian ships began carrying simplified backup systems that could be repaired on the fly, inspired by human emergency protocols. Meridian colonies developed new techniques for adapting to light-poor environments, rather than simply relying on their photosynthetic capabilities. But perhaps the most profound impact came from what became known as the human perspective, the understanding that limitations weren't absolutes, but challenges to be overcome through innovation and determination. During one particularly challenging training exercise, as students from various species worked together to survive conditions that should have killed them all, Alina observed something remarkable. A Meridian student was sharing their photosynthetic energy with a struggling Thraxian, while a crystalline Varaxian used their body to shield others from radiation. They weren't just surviving. They were adapting, innovating, cooperating. You see, she said to her teaching staff, we're not just teaching them to survive like humans. We're teaching them something far more important, that survival isn't a solo endeavor. The galaxy is filled with species that evolved amazing defenses, but humans evolved something unique: the ability to turn impossible situations into opportunities for growth. The Academy's motto, carved in multiple languages above its main entrance, summed up humanity's greatest lesson to the galaxy. Survival is not about being unbreakable. It's about being undefeated. Years later, when a catastrophic series of solar flares threatened an entire sector of space, it wasn't just human emergency teams that responded. Academy graduates from dozens of species worked together, combining their natural abilities with human-inspired adaptation techniques. They didn't just save lives. They established new protocols for thriving in conditions once considered unsurvivable. As Alina watched news of their success, she remembered something she often told new students. Humans don't teach survival because we're the best at it. We teach it because we learned, through millions of years of being seemingly outmatched, that the strongest defense isn't in your body. It's in your mind, your will, and most importantly, in your ability to work together. The galaxy had learned that humans weren't extraordinary because they couldn't be killed. They were extraordinary because they refused to accept defeat, even in death's face. More importantly, they had proven that this trait wasn't uniquely human. It could be taught, shared, and spread throughout the galaxy. In the end, humanity's greatest contribution to galactic civilization wasn't their technology, or their culture, or even their remarkable adaptability. It was the simple yet profound lesson that true survival isn't about being immune to damage. It's about having the will to continue, the creativity to adapt, and the wisdom to know that the strongest survival trait of all is the ability to help others survive too.